Okay, so today I'm going to go over some basics about momentum, and I want to apologize in advance because my puppy is in the background trying to escape from her pen, but unfortunately there's nowhere else I can go to film this, so please just ignore that. So momentum is a physics term that refers to the quantity of motion that an object possesses. Basically, it's the mass and motion of an object, and momentum is directly dependent on velocity. You hear, I'm so sorry, velocity and mass. Okay, so one way that we could think of this is if you think of a horse moving at 10 meters per second, okay, and then you think of another horse moving at 2 meters per second. Sorry, I did that wrong. Another horse moving at 2 meters per second. Oh my goodness, I'm so sorry. She's so annoying. Obviously, the horse moving at the faster speed is going to have a greater momentum. Now let's think if we have a horse moving at 10 meters per second. And a cat moving at 10 meters per second. Which one is going to have the greater momentum? Yep, that is definitely going to be the horse in that situation because it has a greater mass. So you have one horse moving at a greater velocity and another horse moving at a greater mass. Okay, so why is momentum a vector quantity? Momentum is a vector quantity because it has direction. Okay, and that direction, very important, comes from the velocity. Whichever direction the object is moving in is the direction that the momentum is going to be. Okay, so now that you have a qualitative understanding of kind of what momentum is, let's talk about a formula for momentum. Okay, and we use P equals mv. P stands for momentum. So the reason that we use P is because m is already used for mass. And then, of course, v is velocity. So, yeah, we use P for momentum because m is already used for mass and because the Latin term for momentum starts with AP. I'm not going to attempt to pronounce it because that would be bad. Okay, so lastly, how do we change an object's momentum? So, basically, you need to think back to dynamics and think about Newton's first law, which says an object that is in motion will continue to move at a constant velocity unless it's acted on by an external force. So, the object's momentum is going to change when a force is acted on it. So, we can say a force is applied, and that applied force is going to cause a change in velocity. So force is applied, velocity is changed, and when the velocity is changed, sorry, that's kind of messy. When the velocity is changed, you know that the momentum has to be changed as well. All right, let's keep going. So what I want you to do now is take a second, pause the video, work out these example problems, and then unpause it. Okay, so hopefully you just worked out the example problems. The thing to think about is that you want to always use this P equals mv formula. That's the basics for our entire unit. So we're ranking the momentum from least to greatest. So first we have a 1 kilogram cart moving at 4 meters per second. So that's going to be 4 kilograms times meters per second. I did not mention that on the first slide, so let's talk about that real quick. The unit for momentum is kilograms times meters per second because if you look at our formula, it's mass times velocity. Mass is measured in kilograms and velocity is measured in meters per second. Okay, so we have, our 1 kilogram car moving at 4 meters per second. That's going to be 4 kilograms times meters per second. B is going to be 6, same unit. C is also going to be 6, and D is going to be 4. So if you can look at these, I just didn't recopy that unit just to save space, but if you look at these, you can clearly see that A and D have a lesser, have lesser momentum than B and C, and they tie, so that's why we include them. Secondly, let's just say a 1,500 kilogram car, but we have a 1,500 kilogram car traveling due north at 15 meters per second. What is the momentum of the car? So we're going to, once again, say P equals mv here, and we're going to say that momentum is our unknown, 1,500 kilograms is our car, and it's moving due north at 15 meters per second. Our momentum is going to be 22,500 kilograms times meters per second. All right, what are some ways that we could change the momentum of the car in the previous problem? So basically any way that you can change mass or velocity, that's going to change the momentum of the car. So we can say speeding it up, so we can say speed up, slowing it down, changing direction, that's a big one. And then of course we could also change the mass, right? We could add or take out people or objects, and that would change the mass of the car. And all of those things would affect the momentum. All right, the last thing that we're going to talk about today is impulse. So have you ever wondered maybe why football players wear helmets, why gymnasts practice on mats, baseball players wear gloves, or cars have airbags? That is all due to something called impulse. So impulse is the change in momentum. And basically, the faster your momentum changes, the more force is involved, which means it's going to hurt more if you're thinking about yourself. So the formula that we use for impulse, there's actually two. One that we use is, so remember how I said impulse is change in momentum? So one formula that we use is delta P. That's delta is change in, P is momentum. Final momentum minus initial momentum. That's always an option. I'm going to write that a little bit clearer so it makes more sense. Okay, and then another option, of course, we have like a true formula for impulse, and that is change in momentum equals force applied times the time interval. So we'll label all those things too. So that's the force, and that's something that we really call, sorry, that's the puppy again, something that we really call impact time. That's that time interval there. So basically the idea behind this is that if you increase the impact time, you're decreasing the force. So if you increase the impact time, you're decreasing the force, and vice versa. So gymnasts practice on mats. That's a good example. And when they hit the mat, instead of the concrete ground, they fall for longer. That impact time is extended on a mat versus the hard ground. So higher impact time equals lower force, which means the gymnast is less likely to be hurt. Erase that. All right, that's my notes on momentum and impulse. Sorry it was kind of messy, and sorry you had to listen to the puppy in the background. Let me know